afternoon everyone. So today I am going to explain you the concept of an left recursion. So previous class I explained you about the what is an ambiguous grammar and how to convert an ambiguous grammar to an unambiguous grammar. So the next concept is an left recursion. So left recursion is a recursion where the grammar will have any of the production of the form like this. So that is, suppose A is a non-terminal, so that non-terminal determines that same non-terminal at the beginning of the body of the production, then we will call such type of the production, such type of the grammar is a left recursive grammar. That is, any grammar which has a production of this form is called as an left recursion. And elimination of the left recursion is very important because, so I told you already that whenever we will be performing the parsing, there are two methods are there. One is an top-down approach and the other one is an bottom-up approach. So, and already we have saw this bottom-up approach, that is which one? That is YAP program. I told you that YAP programs are the programs which works by using an bottom-up approach, and there is a one more approach where the parsing can be undone, that is an top-down approach. That is an top-down approach. That is, the syntax errors can be identified by using a top-down approach. So when we are planning to use this top-down approaches, we should make sure that whatever the grammar we are using for the parsing, that should not have such type of the left recursion. So that is the purpose we need to eliminate the left recursion. Got it? The top-down parsing, which is used for identification of the syntax error, will not support the grammar which has such type of the production, that is the left recursion. It will not support the left recursion. So as much as possible we need to eliminate this such type of the left recursion. So how to eliminate this left recursion is, suppose if we have any of the grammar, suppose like A determine A alpha beta, where alpha is some string and beta is an some string, sentient form, we will call them as a sentient form. So if we have any of the left recursion of this form, so this will be eliminated by A determine beta, that is this one, A dash, and A dash determine alpha, A dash or epsilon. This is epsilon, empty string. Epsilon is nothing but the empty string. So this is the method for elimination of the left recursion. Suppose if you have any of the immediate left recursion of this form, then what we have to do, suppose if you have A determine A alpha and beta, then we can write this production as set of the two productions, like A determine this what beta A dash. A dash is a one more non-terminal that what we are adding. It is not compulsory that it should be an A dash only. If you want, you can take T, or if you want, you can take it as a F, anything, any non-terminal. We are adding one more non-terminal. So, and A dash determine that whatever the alpha you had, that one, followed by that new non-terminal what we have selected, and or it can also determine the epsilon. So this is the method for elimination of the left recursion. Now we will see a few examples for this elimination of the left recursion. Now we will see some of the examples of this. Let us consider E determine E plus T or T means T star F determine E ID. All of you know that this is the grammar, that is arithmetic grammar, so which doesn't have any ambiguous. That means it is an unambiguous grammar by introducing the term and the factor. All of you know this particular grammar, but this particular grammar cannot be used for a top-down parsing. Why? Because it has an immediate left recursion. E determine E, it is a left recursion. T determine T, so left recursion is there. So this particular grammar cannot be used for an top-down parser. Therefore, we need to eliminate the left recursions, whatever we are having in this grammar. So in order to eliminate this one, so E determine, as I told that we need to introduce the one more non-terminal. Any non-terminal name, convention name you can use. So let it be an E dash. So it is beta. Beta is this one. So it is T into E dash. Correct. Then E dash determine alpha. Alpha is nothing but plus T E dash, or it can be epsilon. Or it can be epsilon. Same thing here, T determine beta. Beta here is F T dash, and T dash determine alpha. Alpha is nothing but star F or epsilon. Here there is no left recursion. So F determine E or ID. So this is the grammar what we got. So after removing the left recursion. Now this particular grammar can be used for top-down parsing technique. So this is an example where we have eliminated the left recursion, and both here whatever the productions are there, they are having the immediate left recursion. They are having immediate left recursion. Now we will see some example where there is no immediate left recursion, but after substitution for some non-terminal we may get the left recursion, and how to eliminate such type of the left recursions. Now let us consider this particular grammar. So in this particular grammar we are having the production, that is S determining AA or B, A determines AC and SD epsilon. Here there is one immediate left recursion is there. So if I will substitute for this particular S, that is AA, we will get one more left recursion. That is, if I will write this as A determine AC, and instead of S I am writing AAD. Okay. So here there is a one more left recursion. So two left recursions are there. Therefore, now I will convert this particular grammar into a grammar where there is no left recursion. So now there are two immediate left recursions are there. So remove those left recursions. So it is S determine AA. Here there is no left recursion, and here A determine AC. That is it. There is a left recursion. So it is nothing but beta. So what is the beta here? Beta is nothing but the one more production you have. Correct. So S determine, we have replaced it with the AA, and sorry, here there is a one more substitution we need to do for this, that is AC. A determine AC. Here instead of S we are writing AAD, and there is one more S determine B is there. So that is, now I am substituting for this production. So that is B, D, and then epsilon. So this particular production now we have converted into this production. Okay, for the substituting for the S, after substituting for an S. So S determine AA, S determine B. So we have substituted for both the body of the production. Now in this there is a left recursion. We need to eliminate the left recursion. Now consider this first production. There is no left recursion here. So write as it is S determine AA and S determine B. So now here there is a left recursion. So it is beta. So what is that beta? So it is nothing but BD here. So it is BD A dash, and also there is one more beta, that is nothing, that is empty string. So simply we need to write the A dash. Now A dash determine alpha. So what is an alpha in this case? It is nothing but the C A dash, and in this case it is AD A dash. Okay. Then epsilon. So this is the final production where there is no left recursion. So this is not an immediate left recursion what we are having in this particular grammar, but after substituting for some non-terminal we are getting left recursion, one more left recursion. So this is the grammar after elimination of the left recursion. So this is an example of elimination of an left recursion. So I'll give you some examples. You solve those examples.